Hello students, welcome to the channel. In our continuing series Target 750 Plus, we look at advanced problems from different topics on SAT and ACT to help you achieve a perfect or near perfect score. Today we look at linear inequalities from SAT and ACT Math. So let's begin. Question 1. On January 1, 2000, there were 175,000 tons of trash in a landfill that had a capacity of 325,000 tons. So there is a landfill. Let's say this is my landfill, and it has a capacity of 325,000 tons. And currently there are about 175,000 tons of trash in the landfill. Each year since then, the amount of trash in the landfill increases by 7,500 tons. So the amount of trash that goes into the landfill per year is 7,500 tons. If Y represents the time in years after January 1, 2000, which of the following inequalities describes the set of years where the landfill is at or above capacity? So when will the landfill be at or above capacity? When the total waste in the landfill is greater than or equal to 325,000, right? Because the capacity of the landfill is 325,000, so it would be at or above its capacity when the total waste is greater than or equal to 325,000. Now, how do I find the total waste? The total waste would be the initial waste, which is 175,000, plus the weight that I have added over Y years. In 1 year, I add 7,500 tons of waste. So in Y years, I would add 7,500 Y, right? So that is the total waste, which is 175,000 plus 7,500 Y, and that should be greater than 325,000. Or 7,500 Y should be greater than 325,000 minus 175,000, which comes to 150,000. So Y should be greater than 150,000 divided by 7,500. That means that Y should be greater than equal to 2. So after 2 years, the landfill would be at capacity. And if you go beyond 2 years, it would be above capacity. Now, interestingly, my options don't give me the value for Y. They leave it at an equation. And the right answer you can see will be option D, because option D is exactly what my equation here says. Option C kind of reverts the equation, right? It is 7,500 Y that should be greater than 150,000, right? So this reverts the equation, or rather inverses the inequality. So this is not correct. And A and B are not correct either, right? So the best answer, the right answer is option D. Okay. Question 2. A recent poll about crime in schools claimed that 67% of Americans approved of a bill being debated in Congress. The poll also reported a 3% margin of error. Which inequality correctly captures X, the percentage of Americans who approved the bill? So there are 67% of Americans who approve it, and there is a 3% margin of error, right? So the lower side, it could go down to 64%, and on the upper side, it could go up to 70%. So X could range from any value between 64 and 70, where X is the number of or rather the percentage of Americans who approved the bill. So I have what is an absolute value inequality in the options, right? So let me first work with option A, right? Let's say I take any value in this range. Let's say I take 65. Then modulus of 65 minus 67 is modulus of -2, which is 2, and that is less than 3. Let me take 69. Modulus of 69 minus 67 is modulus of 2, which is 2, which is also less than 3. So I notice that A seems to satisfy what I'm looking for. And if you think about it from the perspective of what an absolute value function does, I am basically going 3 on the left and 3 on the right. So any number in this range, if I subtract that number for 67, my answer could go from -3 to +3, right? Because if I take 64, then 64 minus 67 is -3. And on the plus side, if I go up to 70, then 70 minus 67 is +3. So the difference of any number in this range from 67, x minus 67, this will be from -3 to +3. And if I put an absolute value on that, then it would simply be from 0 to 3, because the absolute value will ensure that the negative numbers get eliminated. So even logically, the difference of any x from 67 should be from 0 to 3 if you take the absolute value of that difference. And so the right answer is option A. In the xy plane, if a point with coordinates a, b lies in the solution set of the system of inequalities above, what is the maximum possible value of b? Okay, so I have two inequalities. Let me plot them. One inequality is, so what will be the line y equal to minus 15x plus 3000 look like? It would look like this, right? Because it has a negative slope, minus 15, so it's a falling line. And the y-intercept is 3000, right? So that's the first line. What would be the line y equal to 5x look like? It would look like this, right? This is y equal to 5x. The slope is positive 5, so it's a rising line. And it has to go through the origin because it does not have a y-intercept. So this is y is equal to 5x, and this is y equal to negative 15x plus 3000. Now, y less than this would be the region below the first line. Y less than, so this is this region. And the second also is less than, so that is also the region below the second line. So that's just this region. So effectively, the system of inequalities has a solution that is this triangle and everything below this triangle, right? Because that's where the two solutions meet. The brown and the red are both here. So this whole region below the triangle is the solution set for this inequality, this system of inequalities. So if a comma b lies in the solution set, then what is the maximum possible value of b? You can see that this is the highest point where the system of inequalities has a solution. And so the maximum value of b, the y coordinate, will be this point, which happens to be the intersection of these two lines. So I can simply solve these two lines as simultaneous equations, and whatever is the y value of the solution is the maximum value of b. So minus 15x plus 3000 should be 5x. So minus 20x should be negative 3000. So x is 3000 by 20, which is 150. So that's x. And y is 5 times x, which is 5 times 150. So that's 750. So this point becomes 150, 750. And so the maximum possible y coordinate of the solution system is 750. Remember that we can't find the maximum possible x coordinate of this system because this solution system will just extend on both sides. And so the x value on the negative and the positive sides will go on changing, right? So there is no maximum or minimum x value. Okay, let's move on. Question 5. Point xy is a point within this triangle. What is the probability that y is less than x? So we have a triangle here. Let's draw that triangle. We have 0, 10 and 5, 0. And this is how my triangle looks. Now, the point is within this region, and I need to find the probability that y is less than x for this region. So let me first draw the line y equal to x, right? The line y equal to x will be a line with slope 1 and passes through the origin. So the region below this line is the region y less than x. So this little triangle that I have, this triangle within the big triangle is the region where y is less than x. So the required probability, the probability that y is less than x, would be the area of the small triangle, the shaded triangle, divided by the area of the big triangle, the one with 0, 10, origin, and 5, 0 as the vertices, because that's the region we are working with. So how do we find the area of these triangles? The area of the big triangle is very simple. Area of big is just half base into height, where the base is 5 and the height is 10. So that's 25, right? For the area of the small triangle, I have the base 5, but I don't know the height. The height I can get from the y coordinate of this point. And this point is the point of intersection between the line y equal to x and the line joining these 2 points, right? So how can I find the equation of the line joining these 2 points? I can use y is equal to mx plus c, where c, the y-intercept is 10. So this becomes mx plus 10. And m I can find using y2 minus y1 divided by x2 minus x1. So 10 minus 0 is 10 divided by minus 5. So negative 2. The slope is negative 2. So I get y is negative 2x plus 10. So the equation of this line is y is negative 2x plus 10. And the equation of this line is y equal to x. So I can say x is equal to negative 2x plus 10. 3x is 10. So x is 10 by 3. Since y and x are equal here, so this point is 10 by 3, 10 by 3. Which means that this height for the triangle is 10 by 3, the y coordinate of this point. And so the area of the small triangle is half into base into height, which is 10 by 3, which is 25 by 3. And so the probability that a point within the triangle is such that y is less than x is 25 by 3 by 25, which is 1 by 3, option B. Right. So those were 5 problems from linear inequalities. Hope you found this video useful. If you did, hit like and subscribe to the channel. Let me know in the comment section what other videos you'd like me to upload, and I'll try working on them. I'll see you guys in a new video soon. Take care. Bye-bye.